The human body's framework. Let's take a journey into the fascinating world of osteology. That's bone study, if you aren't up to snuff on your medical jargon. Because, as a frame supports a building, our skeleton is the architectural marvel that props us up, allowing us to move, dance, and sometimes perform ill-advised skateboard stunts. A long bone, which I swear is not a term I just made up, is characterized by its elongated shape and is primarily found in our limbs. The anatomy of a typical long bone can be broken down fairly neatly. Dive in with me. The diaphysis, the long stretch. At the heart of it all is the diaphysis, the central shaft of the long bone. This is the straight, tubular portion made primarily of compact bone. Think of it as the dense part. Not dense as in that one friend who doesn't get the joke, but as in the types of cells are packed tightly to give strength. It's like the steel beams within the walls of a skyscraper. The epiphyses, both ends of the spectrum. Plunked at each end of the diaphysis are the epiphyses. These are the expanded areas that provide the connection to the adjacent bones at the joints. Their outer region is composed of compact bone, while the inner section boasts a spongy texture dense with bone marrow. Why the combination? Well, it has to do with reducing the weight of the bone without compromising its structural integrity, nature's own version of smart engineering. The metaphysis, transition, is the game. Transitioning between the diaphysis and epiphyses, you'll find the metaphyses. These zones include the epiphyseal plates, popularly known as growth plates in kids and adolescents. This is where the magic of growth happens during our early years. It's a bustling hub of new bone generation until early adulthood, when it ossifies and waves the white flag on the growth battle. The periosteum, wrapping it up. Imagine shrink wrapping your bones, but instead of plastic, your body uses a dense layer of connective tissue called the periosteum. This important surface not only nourishes and protects the bone, but also serves as an anchor point for muscles and tendons. It's literally where the action of muscle gets translated into the motion of bone. The medullary cavity, hollowed grounds inside the diaphysis, lies the medullary cavity, a hollowed-out region lined with yet another layer called the endosteum. Here, we find the bone marrow. Now, this isn't the kind you spread on toast. It's a richly vascular tissue involved in making blood cells. It's also where the fat gets stored, known as yellow marrow, a sort of biological reserve fuel tank. The articular cartilage, slip and slide. Where our bones meet, you'll find a smooth white tissue called articular cartilage. This isn't like the cartilage in your ears or nose. It's got a crucial role in reducing friction and absorbing shock at the joints. Without it, the bone-on-bone action would be a horror show and quite literally a grinding experience. There it is, the basic anatomy of a long bone, serving as both the framework and foundation of our daily activities. From walking through the peaceful, tree-lined streets of Portland to raising a hand in lecture or at a concert, long bones are unrecognized and unsung heroes of our bodily functions. And that's just scratching the surface, quite literally, considering how much goes on inside those pivotal structures. But hopefully, that gives you a skeleton, pun intended, of what a long bone is all about.